2, imaginary and complex numbers. So we've talked about the fact that complex numbers were going to be coming along, and imaginary numbers, and here we are. So our objective is to write a complex number in standard form and perform operations with them. Have you ever thought about the solution to x squared plus 4? Remember how we said before we couldn't do it? Yeah. Now we're going to be able to. I is the imaginary unit. I is equal to that square root of a negative number. And if we squared both sides, that would cancel, right? And we'd end up with I squared equals negative 1. So, for example, x squared plus 4. Well, we minus 4 like we've done before. And before, we would just stop. Okay? And because we couldn't do that, we square root both sides, and we end up with that square root of a negative number. But now what we can do is, since I squared is negative 1, we can rewrite this as negative 1, I don't know what's happening. Try to write a negative 1, there you go, times 4. So now the negative 1 comes out as an I. We don't have to do this in 2 steps, I'm just showing you. And then we don't want to forget our plus or minus. And like I said, you can go from one here to here. I just want to show you why that's happening. And we don't want to forget the plus or minus because when we're solving equations with square roots, we want to have plus or minus. Because the square root of 4 is both positive 2 and negative 2. So we cannot get a real solution to this problem, so we're going to use the imaginary unit. So again, we're going to subtract 32 from both sides. Then we end up taking the square root of both sides, which leaves us with x equals the square root of negative 32, which can be rewritten as negative 1 times 32. And then remember, this breaks down to 16 and 2, technically square root. So the 16 is going to come out. We always put plus or minus when we're doing equations. So the 16 comes out as a 4, and the negative 1 comes out as an I, and what's left inside? The 2. And that's our answer. Then we're going to add 36 to both sides. Negative 2x squared equals positive 36. But now when we divide by negative 2, again, we end up with x squared equals negative 18. We square root both sides, and we get x equals plus or minus square root. Now, if you want to, you can just break it down right here. Negative 1 times 9 times 2. It's another way of doing it all in one step. And then we just pull stuff out. Don't forget the plus or minus. The 9 comes out as a 3. The negative 1 comes out as I. And the 2 is stuck underneath the radical. Okay, a little bit of work to do here. First, we're going to move the 100 over. So we have 4 x minus 5 in parentheses squared equals negative 100. Then we're going to divide by 4. X minus 5 squared equals negative 25. Square root both sides, and we're left with x minus 5, still squared, equals, now remember, this is really negative 1 times 25, so you can write it that way also. So you could go right to this, whatever your comfort level is, and that's going to come out as plus or minus 5i. Square root of 25 is 5, square root of negative 1 is I. I don't know why I left my radical here, sorry. My square root. cancel, so x minus 5. Now I'm going to add 5 to both sides. I end up with positive 5 plus or minus 5i. Okay, pure imaginary numbers. This is the square root of negative numbers such as 36, 4, okay? So, negative 36, square root of 36 is 6. Square root of negative 36 is 6i. Now, we can have a negative outside. That's okay. This just says the opposite of the square root of negative 4, which is just negative 2i. Or we can have plus or minus square root of negative 5, which equals plus or minus I square root of 5. Okay, these are pure imaginary numbers because they just have the radical. And they might have a coefficient in front. But then we get into complex numbers. Complex numbers, as we had last night in our homework, we've already had some of the examples here, is when you have a number added to or subtracting the imaginary units, such as 2 plus 5i, negative 3 plus 4i, negative 1 minus 2i. These are all in the form of a plus bi. We always want to put that number in front of the bi. So when real numbers and imaginary numbers come together, they form complex numbers. So real numbers are we have like negative 3, and 5, and 10. Imaginary numbers are 2i, negative 5i, and so forth. So then we put them together, we have something like 10 minus 2i. Okay, now this, the powers of I. You just simply need to know this because we're going to learn a shortcut with this. So I is obviously just I. I squared is negative 1. I to the third power is negative I, and I to the fourth power is 1. Now why is I to the fourth power 1? Well, that's because you get I squared times I squared equals I to the fourth, right? And since I squared is negative 1 times negative 1, that equals positive 1. So you can always work backwards and figure this out. Now, what you want to do is we want to use this magic I to the fourth because it's 1 and it just kind of clears out a bunch of i's. So I to the sixth we can rewrite as I to the fourth times I squared. And since I to the fourth is simply just 1, that leaves us with I squared, which is negative 1. So it's like every 4 of them leave as 1. Okay? So we're going to divide 23 by 4. 4 goes into 23 5 times. Okay? So those are all gone. So what does that leave? I cubed, which is negative I. Now again, why did I do that? Because I can take, technically, I to the fourth times I to the fourth times I to the fourth times I to the fourth. You don't have to write this all out every time, I'm just showing you. Times I to the fourth. 1, 2, 3, 4, 5. Every one of those I to the fourths is 1. And this is 4, 8, 12, 16, 20. So that takes care of 20 of those i's. They're gone. How many are left? 3. And I cubed is negative 1. So we can always bring everything back to this chart. So I to the 40. Well, how many times is 40 divided by 4? 10 times, right? 4 goes in evenly. So every group of 4 is 1. And since there's 10 groups of 1, that ends up just being positive 1. 37, how many times does 4 go into 37? 9 times 4 is 36, right? Okay, so that means these 9 groups are all 9 ones. 1 times 1 times 1 times 1, 9 times. How many i's does that leave over? Just one I to the first power. I know it might be a little mind-blowing at first, but we'll practice that and it'll be okay. Okay, operations. We treat I just like a variable. So adding and subtracting complex numbers. Add and subtract the real parts, add and subtract the imaginary parts, then write the final number in the form a plus bi. So, we're going to join like terms. 3 plus 9 is 12. 5i minus 2i is plus 3i. Same way as if it was 3 plus 5x and 9 minus 5x. Same idea. Here we're going to distribute the negative, as we would if it was 4x, negative 4x. So again, 5 plus negative 7 is negative 2. 8i plus 4i is plus 12i. And remember, that's because this is really negative 7 plus 4i after I distribute the negative sign. So negative 7 plus 5 is negative 2, and negative 4i, positive 4i plus 8i is 12i. Okay, multiplying. Same thing. We're going to treat it as if it was a variable. And every time we end up with an I squared, we're going to replace it with negative 1. So, here we go. Exactly like this, if it was this 2x times 4x. We get 8x squared. The difference is here we're going to get 8i squared. But remember, I squared is really negative 1. So this is negative 8. We don't have to take this step to rewrite it, but if it helps you, go ahead. If you can just change it right here to negative 1 and do it in your head, that's fine. Now we're going to FOIL. First, outer, inner, last, like we've always done. 2 times 6 is 12. Plus outer, negative 4i. Inner, plus 18i. Last, plus times negative is negative 12i squared. So in the middle, we have 18i minus 4i, which is 14i. Then we have a 12, that's negative 1. That negative 1 is really going to be negative 12 times negative 1, which is going to make this positive 12. So we're really adding 12 plus 12, that's going to be 24. Remember, we want to put the a in front of the bi. And last, dividing. A plus bi and a minus bi are complex conjugates. We've already dealt with conjugates before. And remember, you cannot have an imaginary or complex number in the denominator. So we're going to multiply the top and bottom by the conjugate, which we've already done before. Replace every I squared with negative 1 and simplify. So, we're going to multiply the top here by 5i and the bottom by 5i. We're going to distribute here. So, 5i times 3 is 15i minus 10i squared. That's on the top. On the bottom, we're going to end up with 25i squared. And each of these I squareds we're going to replace with a negative 1. So on the top, the negative 1 is going to be negative 10, positive 10. I'm moving it to the front. Plus 15i. On the bottom, that's going to make it negative 25. And then I'm just going to simplify. Because I can write this as 10 over negative 25 plus 15i over negative 25. Which is going to be 5 goes to the 10 twice. It's going to be negative 2/5 minus 5 goes to 15 3 times. 5 goes to 25 5 times. this conjugate here is 3 plus 2i. So we're going to multiply that by 3 plus 2i on the top, 3 plus 2i on the bottom. And FOIL, and FOIL. 4 times 3, 12. Outer plus
With Maddie Walker.
4 times 2i is 8i. Inside, that gives 3i. And on the outside, last times last, plus 2i squared. Remember, we are negative 1. On the bottom, 3 times 3 is 9. Remember, the inside term is going to drop out, so we just review first and last. So it's going to be minus 4i squared, which is going to be negative 1. Now we just simplify everything. On the top, this negative 1 is going to make 2 negative, so that's 12 minus 2 is 10. Plus, 8i plus 3i is 11i. On the bottom, the I squared is going to make 4 positive, so that's 9 plus 4, which is 13. That's as far as we can go.